Section 3.2 is going to continue our discussion of quadratics, but it's going to expand it to do things in general for polynomials. So polynomials means that you could have x cubed or x to the fourth or anything higher than that as well. So we won't just have quadratics now. We'll expand it a little bit. We're going to look specifically at zeros. So zeros means x-intercepts or places where our function, whatever they are, equals 0. So to start with, we've got a couple of theorems to jot down. The first one's called the remainder theorem. The remainder theorem says that when a polynomial is divided by x minus c, the remainder is p of c. In other words, it's the same thing you would get if you plugged c into the equation. That's your remainder. And then kind of serving hand in hand with that is the factor theorem. The remainder theorem says you can divide by x minus c, but you might get a remainder, right? It's kind of the equivalent of saying, well, I mean, I can divide 9 by 2, but it doesn't go in evenly, right? It doesn't. I mean, like in terms of a whole number. The factor theorem says that if it is a factor, right, if it does divide it evenly, then you're going to get a remainder of 0. So c would be a 0 of p of x. So 2 does not divide 9 evenly because I get a remainder, but 2 divides 8 evenly because I don't get a remainder. I get a remainder of 0. And this is the equivalent of that for polynomials. Okay, I promise I'm not going to ask you to like guide me through it or anything, but does anyone remember doing, at least even vaguely, synthetic division in high school? Just show of hands. Does anybody remember doing that? Okay, so about a third of you do. Synthetic division is a really nice abbreviated process for doing division of polynomials. There's a long division of polynomials as well, but it's more difficult. So I'm going to show you synthetic division, at least for now, for dividing polynomials. So question number 1 says, use synthetic division to find the quotient and the remainder when the quadratic x squared minus 3x plus 9 is divided by x minus 4. A lot of verbiage. Okay, so we're going to do several synthetic divisions, so don't get frustrated if you're like, I don't remember where all the pieces went. We're going to do several of them. So the first thing to recognize is that there are coefficients in front of my terms, right? There's a 1 in front of x squared. Let me use the white. There's a negative 3 in front of x, and there's a 9 here, right? So we're going to abbreviate everything we do by only looking at the coefficients. That's part of synthetic division. Over here, we're going to set this equal to 0 and solve. So if I take x minus 4 and I add a 4 to both sides, I get x is equal to 4, right? You don't even necessarily need to show me that. You can do that in your head. That's great, no problem. This value goes on the outside of the synthetic division. And I put it in a box, kind of separating it from the rest. What happens next is all those coefficients that I identified here go beside it. Okay, after the box. I've got a 1, I've got a negative 3, and I've got a 9. Okay, so far I've eliminated all the variables that I was talking with, and I'm now just looking at numbers. Okay? Everybody good so far? Okay, so what we do with synthetic division is we're going to leave sort of a space. I'm going to put some numbers between the numbers I already have in this line. So leave yourself a line on your paper or whatever. You've got some space on your paper. The first thing you do is you bring the 1 straight down. That step's easy. Everything we're going to do as we work through this whole step is 3rd grade math. Okay? We're going to be adding, subtracting, multiplying, dividing. All stuff that you would be very competent doing in 3rd grade. The computations are not the problem. Maybe remembering the order of them might be something, but the computations themselves are not hard. So the first thing you do is you bring the 1 down. After you do that, you multiply this 1 by 4. That gives you 4. And you write it right here underneath the 3. Okay? So this number comes from multiplying these two together. And then you add down. So negative 3 and positive 4 is 1. Okay? So we're adding down. And it's kind of like, on the shampoo bottle where it says wash, rinse, repeat. You know what I'm talking about, right? You do the same thing again. You take that 1. It happens to be the same number, I know, but you multiply it by a 4. That gives you a 4. And you write that down underneath the 9. And then you add down. 9 plus 4 is 13. Now, I'm going to box this off at the end as well, because this gives me two separate answers at the end. The answer that I've boxed off is the remainder. I mean, it flat out is. There's nothing to do with it or anything. It asked what's the quotient, what's the remainder. The remainder is 13. Okay? This piece right here allows me to write the quotient, the quotient that I haven't written yet. Now, it's not the quotient. The quotient is not 1, 1, or 11 or something like that. That's not the quotient. But these right here correspond to, just like they did before, coefficients in front of the polynomial. So if you think about what happened here, this column right here was the x squared column, this was the x column, and this was the constant or the number column, right? That's where those numbers came from. When you divide, these values at the end correspond to the same kind of thing, but they don't stay x squared, they go down by 1 degree. This is now the x column, and this is the number column, and this is the remainder column. So this x has a coefficient of 1, so it's 1x, or you could just write x. There's a 1 right here, that's the constant, and that's my quotient. So my quotient is x plus 1, or 1x plus 1. That's kind of running into things, so I'm going to just delete it for now. So my quotient is x plus 1. My remainder is 13. Okay, is that right? Okay, so I'm going to change the directions just a little bit, but I'm going to do the synthetic division with you one more time just so we've seen it twice today before we pause, okay? The directions over here say simply to find f of negative 1 using synthetic division. It's very specific. Obviously, I know you could put negative 1 and just plug it in. That's not the point of this particular problem. They're wanting you to practice again using synthetic division to find the same quotient, or the same remainder, the same value. So what do? Well, this negative 1, it's kind of nice because the negative 1 they give you is what automatically goes on the outside. You don't have to sort of do anything to work for it. Over here, we had to set this equal to 0 to find x equal 4. They just give you the negative 1, it goes on the outside. Much like I did before, I'm going to have these columns, but they're going to start with x cubed because that's my highest degree. I'm going to have an x cubed column, an x squared column, an x column, and a number column. What's the coefficient in front of x cubed? 1. How about x squared? Negative 4. How about x? 0. So I put these headers on here, not because they have to be on there, but because I want you to remember every power has to have a coefficient. So there's not an x in this equation, right? I mean, not by itself. There's not like a 5x. It's not there. So there is a 0x there, and I need a placeholder 0, just like if you wrote down the number 107, you don't just write the 1 and the 7. You need the 0 as the tens placeholder in the middle. I need the 0 as the x placeholder. And then my number, I don't know why it says number 1, just should say number, is the 8 at the end. Okay, so let's go through the synthetic division process. We bring the 1 down. We multiply 1 by the negative 1 on the outside, and we get negative 1. We add down negative 4 and negative 1. Negative 5, we just crossed over into 6th grade math because we're now dealing with adding negatives, just so you know, in all honesty, right? I have now -5 and -1 on the outside, so -5 and -1 is 5. I add down to get a 5. Multiply my 5 times my -1 to get -5. I add down to get 3. And this right here is the answer to the question. F of -1 equals 3. And if you wanted to confirm it, you could plug -1 into the equation just like you've done always in the past before, and it will give you the same 3, and you could confirm from that direction. All right, we will continue in section 3.2 next time.